Hi. So welcome to lesson number 2, module 11 of the Big Data and Hadoop Developer course. So in this lesson, we'll be concentrating HBase as a solution. So before we proceed with the lesson, let's have a quick recap of the previous lesson. So in the previous lesson, we have learned what is NoSQL, its history, its comparison with RDBMS, and the scalability comparison as well as where NoSQL is exactly used. So in this lesson, we will be learning what are some of the real-time scenarios where NoSQL databases are used and what are the characteristics needed for a solution such as HBase to give a result in such situations. So let's begin our discussion by comparing three of the most popular social media platforms in the world such as Twitter, Facebook, and LinkedIn. So let's have a look at the Twitter page of a particular person. For example, I have shown you here the Twitter page of Bill Gates, and let's see what is so interesting about this. So the first thing is real-time data. If you ever thought about how Twitter is managing all this data, whenever you log into Twitter, you are able to see all the tweets in real time, and you can filter the tweets based on hashtags. You have the recommendation that which person you might be able to follow, and you have recommendations from sites or even companies whom you would like to follow in Twitter. All this happens in real time. Now if you think about Twitter, their database might be having millions of data, millions of rows, and they have millions of users also. So how is it possible that all this vast amount of unstructured data is sorted and given to these millions of users in real time? So that is one question we are trying to answer here. Let's move on. Think about this particular page. Now this is actually the page of Roger Federer. I just took it as an example, but if you look at the right hand side bottom corner, you can see an advertisement, right? So how does these advertisements work in real time, right? So you might have seen these advertisements many times. Whenever you visit social media platforms such as Facebook, you automatically get an advertisement on the right hand side. Now it is not that you just get an advertisement, this comes in real time. So think about Facebook. Facebook has 1.5 billion users, right? And most of them are online most of the time. So they have to manage to show advertisements relevant to each person depending on what they like, how many pages they visit, and how much time they stay on a particular page. For example, if I visit Facebook and if I stay on a particular page which is about sports equipments for, let's say, more than 30 seconds, then that means I'm interested in sports equipments. I should be shown an ad of sports equipment. This seems really simple for a single user. How do you do this for 1.5 billion users in real time? That's a real question, right? And if you look at the data that Facebook holds behind the scenes, it is petabytes and petabytes of data. Now, we know that for a matter of fact that Hadoop cannot do this. Hadoop is a batch processing solution. So there might be somebody sitting there, some sort of a database, who is providing all these answers in real time. So here we have the LinkedIn page of Doug Cutting, who is the founder of Hadoop. So we should be thankful to this person because that is the reason we have Hadoop today. Now, the reason I'm showing this is when you look at your LinkedIn page or anybody's LinkedIn page, you can easily see a lot of additional information such as people also viewed. Or if you add a particular person to your connection, you easily get another option saying that suggestions. So how does these suggestions and connections work in real time? So if you think about LinkedIn's database, they might be using some sort of a real-time solution wherein they can query behind the scene in less than a second and give you the options for all the users. So what are these common factors that are there with all these websites? One thing is information which is updated to the second or the real-time information. Now the users need not wait. Depending on the page they visit, the amount of time they spend on a page, they get real-time information and contextual suggestions and recommendations. Like in Facebook, when you visit a particular page and stay there for let's say 30 to 40 seconds, you get instant recommendations. And targeted advertisement, that means based on the location from where you're coming from and your gender and your likes, you will be getting advertisements. And extremely quick response, reliability, and the scale of operation. So all these factors are common for all these websites, whether it is Facebook, LinkedIn, or even Twitter. They all have these common factors. Now all these websites are also having huge amount of data, right? They all deal with big data and they do not stick to only structured data. Most of them are providing unstructured data, right? So if you go to your Facebook profile, you know that you have pictures, videos, and check-in statistics, everything which is completely unstructured. But if you visit your profile is not unstructured. Your profile is perfectly structured. You can see that in real time as a timeline flow. So that means they're using some sort of a variable schema. And so the necessity here is to present the data in a structured way which can be accessed in real time and random. So that is very important. So all these websites, even though they are having unstructured data behind the scenes, they must show the users that in a structured way in real time, and users should be able to access data in random. So I should be able to see a tweet which was tweeted like 10 years back, and the next moment I want to see a tweet which just tweeted an hour ago. So there is random access. And since you are dealing with massive amount of data, it should be compressed, I should say, and it should be sharded. Sharding means dividing. So the ideal NoSQL database which can do this for you should be able to compress your data and shard it as well. So these websites would require a database that can. So that is where we are coming to HBase. We will explain that in detail. Now, if you are the architect of one of these companies which we just discussed, you might be thinking about a possible solution, a database which can sort and store the data to enable faster search and retrieval. So sorting is very important since these websites are storing massive amount of data. So they should be able to sort it on their own and present the users with the relevant information and store the data in a distributed environment with faster response. And they should be able to use something called sparse data store. Now what is this sparse data store? You understand that when we are using RDBMS, and if you do not have values in certain fields, RDBMS stores those fields as null values, right? However, these null values will actually take hard disk space. That means even though the value is null on a particular field, when you store the table on your hard disk, it will take some space. Now in the world of big data, this is completely unacceptable. The reason for that is when you are dealing with millions and billions of rows in a table, if you leave maybe a column or couple of columns as null, then you are talking about millions of null values, and that means a lot of space on the hard disk. So in such cases, what happens is that NoSQL uses something called as a sparse matrix. Using the sparse matrix, it will not store any null values. So that is called the sparse data store. And they should also have the automatic sharding feature. What automatic sharding means is that as the size of the database increases, automatically the database solution should be able to divide it into different parts called data shards and store it in different places. And they should be fault tolerant, and real-time queries should be answered by them. All these requirements are met by the default NoSQL database in the world of Hadoop, that is called HBase, and we will be looking at HBase in the coming slides. So to wrap up, in this lesson we have learned about how the NoSQL databases are solving real-time problems such as R targeting and connection suggestions and real-time data, and what are some of the characteristics that must be there for a possible NoSQL candidate such as HBase. That's all for this lesson.